Welcome. My name is Heather, and I'm excited to share with you my implementation of an 8th grade science 5E instructional model lesson on galaxies. On this page, you'll find an implementation overview, which provides a glimpse into the organization and key components of this lesson. As a 5E lesson, students are immersed in activities that engage them, allow them to explore, provide them with explanations, and support the deepening of their understandings through elaboration. Additionally, evaluation can be done by the teacher throughout, leading to a more formal performance task at the end of the lesson. Students are also asked to evaluate their own ideas, as they're given the chance to revise and build upon their initial thoughts. The lesson presentation slideshow will provide you with everything you need to successfully implement this lesson in your own classroom. For quick access to the different sections, please click on the links on the content page. To give you a better understanding of how this lesson was implemented, demographic information has been provided, but the name of the school and district have been changed. As you can see, this lesson was implemented at a diverse school with its own unique set of challenges, including students who are socioeconomically disadvantaged, students with disabilities, and students who are English learners. The objective and goals for this lesson were written to support two of the next generation science standards included in the 8th grade integrated model, MS-ESS 1-2 and MS-PS 2-4. During this lesson, students will be learning about the role of gravity within the different types of galaxies, while at the same time studying the relationship between mass and gravitational attraction. Before we discuss the details of this lesson, it's important to acknowledge the experiences and challenges of struggling students in classrooms. In this presentation, you will find a composite of a struggling student, Riley. As you read about Riley, you may be reminded of a student you have or have had in the past. Some strategies to support Riley and improve their academic outcomes are provided, and many of these strategies are either included or can be easily added to this lesson. Additionally, a composite of a struggling classroom has been provided. Like with Riley, this classroom may sound very familiar to you. Strategies and practices aimed at improving the academic outcomes of this classroom have also been provided. The goal with these composites is to recognize our struggling students and highlight them in an effort to close the achievement gap. In order for students to be fully able to access this lesson, there are some prerequisite skills and knowledge they must possess. Many of these concepts, such as organization within the universe and the force of gravity, are covered in the lessons leading up to this 5E lesson, but others are skills that may need to be reviewed or revisited, such as modeling or arguing from evidence. As you may know, the next generation science standards are three-dimensional. They include a disciplinary core idea, or DCI, a science and engineering practice, or SEP, and a cross-cutting concept, or CCC. On the right-hand side of the slide, you can see these standards being deconstructed down to the 3 dimensions. It's important to note that in addition to the content, students are expected to develop and use models and argue from evidence as part of the science and engineering practices. The cross-cutting concept of systems and system models helps to connect and bridge this particular topic with other science topics and domains. This lesson is part of a much larger unit on the universe, galaxies, stars, and planetary systems. As you can see on this slide, the 5E lesson sequence begins on day 3 and runs through day 7. However, flexibility is essential for proper implementation, and the lesson can easily be compacted or extended based on students' needs. Prior to this lesson, students are introduced to the universe and the things found within. Students then get the opportunity to focus on galaxies in the universe with this 5E lesson. As you can see, students are experiencing multiple E's each day. Some stages, like Explore and Explain, are incorporated more than once. As an initial engagement, students are shown images of galaxies and an animation of galaxies colliding. Presented in Pear Deck, students are able to record their observations and questions, which will fuel their curiosity and inspire their learning. On the same day, students will complete a galaxy sort using the interactive whiteboard Jamboard. Working collaboratively, students will first share their prior knowledge and additional questions about galaxies before developing a classification scheme for galaxies based on galaxy images. Additionally, students will be introduced to unique and memorable galaxies, allowing them additional opportunities to explore galaxy characteristics. As part of the Explain stage, students will dig into a reading from NASA called About Galaxies. As they read, students will annotate using Kami and connect their reading back to their exploration experience. Focus questions and comprehension questions will guide students as they read. Additionally, a narrated version of the reading will support struggling readers. Students will continue in the Explain stage by creating a model to explain galaxy shape, gravity, and motion. Providing choice as differentiation is emphasized during this part of the lesson, as students are given a variety of options for developing their models. This model then becomes the key player in another exploration activity. Students explore potential outcomes for their modeled galaxies when presented with new scenarios, including galaxies with different masses approaching their galaxy. Students make predictions in addition to using their models to show these new situations. By exploring a website on satellite galaxies and using a computer interactive on galaxy collisions, galaxy interactions are explained, and students are able to go back to their predictions and make adjustments. The culminating project for this unit requires students to design and present their own planetary system. And as a first step and an opportunity for elaboration, students will be researching the galaxy that their planetary system will reside in. Students can either use a real galaxy or create one themselves. A performance task rounds out the 5E lesson by having students apply their understanding of galaxies to a set of challenges. The results of this assessment provide valuable data and opportunities for reteaching or intervention. After the 5E lesson sequence, the unit continues with a closer look at gravity in space, stars, and the solar system. Here, you can find a detailed lesson plan for the 5E lesson. If you click on the image, you'll be taken to the lesson plan in a Google Doc. Within the lesson plan are links to all the required resources. These resources can also be found at the end of this presentation. This lesson was implemented during distance learning, and so its presentation may differ greatly from yours. This slide outlines some of the important details of the lesson presentation. This lesson was done during synchronous learning with Zoom as the online meeting platform and Google Classroom as the learning management system. The meetings lasted the entire period. However, students were given time to work independently or in groups utilizing Zoom breakout rooms. Students were monitored and provided with feedback throughout the lesson in a variety of ways. Pear Deck and Google Docs provide great opportunities for monitoring and feedback. In addition, webcams allowed for observations of student behavior. Communication with students via Zoom private chat, Google Doc and Google Classroom comments, and email, in addition to office hours and tutorial time, helped to provide necessary help, guidance, and support for students. As you can see, a variety of technology tools were used throughout this lesson. One particular tool I wanted to emphasize is the Galaxy Zoo website. This technology tool allows students to participate in a citizen science opportunity. The website allows students to see real images of galaxies and classify them. By answering a series of classification questions, students are helping scientists with their research. Some students may even be lucky enough to be the first person to ever see one of these pictured galaxies. Here you can find the resources required for each part of this lesson. We have the Engage Pear Deck activity, Gazing at Galaxies, the Explore Galaxy Sort Jamboard, and Galaxy Zoo Citizen Scientist Opportunity, the Explain NASA About Galaxies reading, with a narrated copy for struggling readers and comprehension questions with answer key. On the next slide, we have the Explain Galaxy Model Development instructions and the Explore and Explain Galaxy Interaction Prediction activity. The resources for satellite galaxies and galaxy collisions, which help explain these interactions, are also provided. The Elaborate Planetary Project Planning and online resources for inspiration are also shown on this slide. And the last resource is the Galaxy Performance Task for evaluating students. Results, findings, and recommendations for the implementation are also found on this webpage. One of the most notable results was the high engagement and curiosity seen in students. Additionally, students were provided with shared experiences that supported lively discussions and the communal construction of knowledge. There were many key findings from this implementation. Engage and explore activities created a need to know in students, which fueled their learning. Activities supported both critical and creative thinking and helped students construct knowledge. Students were able to go back and revise or build upon their previous ideas as they acquired new learning. Additionally, the 5E instructional model challenged students with higher depth of knowledge levels and challenged them to apply their learning to new situations. Going back to the composite of a struggling student, the 5E lesson supported Riley's curiosity, but provided a structured environment for their questions. With more emphasis on discovery and opportunities to go back and make adjustments to initial thinking, Riley is less focused on if they're doing things right and more willing to take risks. Working on the final project piece by piece allows the big project to be presented in a more manageable chunks for Riley, and this gives additional opportunity for feedback and support. With respect to the struggling classroom, this lesson provides scaffolds and accommodations with plenty of room for more. The use of visuals and small group instruction are helpful with this particular classroom. Additionally, having highly engaging lessons help curtail some of the behavior issues that are present with this class. For teachers that are hoping to implement this lesson in their own classrooms, I provided some helpful recommendations. Many students may actually require support when asking questions. Strategies such as sentence starters or turning statements into questions can help students become better at this practice. Additional opportunities for engagement, either to be used at the start of the lesson or to re-engage at another point of this lesson, using weird galaxies is also recommended. When students use Jamboard, having each student in a group use a different color to write or type can keep these students accountable and help the teacher to better assess student understanding. When students create their models, many students benefit from seeing examples. However, examples can also be stifling to student creativity. Providing multiple partial or incomplete examples can help students with their ideas while discouraging them from completely copying an example. For the struggling student, Riley, the narrated reading is highly recommended, along with the other support such as a reference guide for tricky vocabulary or pre-annotating Riley's reading. Additionally, since Riley struggles with work completion, regular check-ins with clear expectations on what should be accomplished before the teacher returns is definitely recommended. Allowing Riley to be guided by their own questions is also helpful. For the struggling classroom, taking visuals to the next level by including hand gestures and animations can help further explain and illustrate concepts. If ongoing assessment shows a wide range of readiness, lessons can be easily tiered for students who need adapted or expanded experiences. Supports for diverse learners are essential, and many materials can be translated into L1 for English learners. A struggling classroom would particularly benefit from multiple re-engagements. I hope this overview has been helpful, and I wish you the best of luck in your own implementation. Thank you.